Hello. So I want to tell you why I think the Moderna vaccine data is extremely exciting, and I think it's stuff that the public needs to know. I'm not an expert, but I think this is important for everybody to understand. So what happens in a cell, we could make an analogy to what happens in cooking. So there's this big central thing right here called the nucleus. And the nucleus is made up of this chemical called DNA that has this kind of windy, loopy kind of thing with these little things that stick out like base pairs. Basically, it's like a book. An analogy to the DNA to the nucleus with its DNA would be a cookbook. So it's a big central cookbook. It tells you how to make things. When a cell needs to make one of those things, what it needs to first do is, when I cook, I do not open the big cookbook. What I do is I photocopy one of the recipes. That way I could make one, my kids could make one, I could send it around and my friends could make one. It's much easier to deal with recipe pages. So the cell photocopies one of the recipes from the molecule, which is DNA, and makes a copy into a very similar molecule called RNA. And it sends that out of the nucleus and into part of the cell that's called the cytoplasm. That RNA, which is a copy of one of the recipes in the cookbook, it's like a photocopied recipe. So the DNA is like the full cookbook, and the RNA is like one sheet of photocopied recipe. Now here's what's important to know. This photocopying process is easy. It happens fast. You could do it in the cell. You could do it in a lab. It's copying this DNA molecule. It's built to look like text. It's built to be instructions. It's built to be easy to replicate. Not only can you easily turn DNA into a photocopy an RNA page, you could photocopy many recipes of this copy for your friends. You could run off 40 copies. You could run off 1,000 copies. So to copy RNA is relatively easy. Now here's the hard step. The hard step is then you take your recipe into the kitchen and you cook and make a big mess, and then eventually you get your dinner. The dinner is the protein. And the kitchen, the factory of the cell that turns the recipe, the RNA recipe, into your protein is called the ribosome, and that's not easy. Making protein is hard, but making RNA and even DNA, but making these RNA copies is relatively easy. So it's back, we'll turn our attention to the Moderna vaccine, which is an RNA vaccine. So before we turn our attention to that, I want to give a very brief, almost like crudely brief overview of immunology. So if you imagine, or a vaccine immunology. So if you imagine, this is the COVID virus. It has like a central core that has nucleic acid, and then it has these proteins on its spike. And one of the ways, so it's like a central core, it's this core, and then it has these proteins that stick out. And it gets into cells and does damage. But one of the ways the body fights it is that there are these cells called B cells, and they make proteins from their DNA, they make RNA, and then it makes protein, and the protein is called an antibody. And what the antibody can do is fit perfectly onto the protein of the virus. So the antibody can fit perfectly onto the protein of the virus and neutralize it. So see how these antibodies, they fit perfectly, and they bind and they neutralize this guy. Because these antibodies which are made, this B cell is pumping out these antibodies, and they're binding to the virus. And the part of the virus, the protein that the antibody binds to get the vernacular, is called the antigen. So the antibodies are basically proteins that are made by the cell that bind to a protein on the virus and fit it perfectly and neutralize it. There is another type of immune cell called T cells, and instead of making antibodies, what they do is they're able to make these things called T cell receptors that can go directly with a cell on it, sort of directly up to the virus, bind it directly, and then the cell will release certain things that can kill the virus. So this is called T-cell immunity or cellular immunity, but we won't focus on that. And by and large, the immunity that may be enough to counter COVID will be antibody immunity, this one, antibody immunity. So really the problem is that when we get sick, let's say we're exposed to a virus here, it takes time to build up antibodies, and we only have enough here to totally clear the antibodies, and this could take 1 to 2 weeks. And then, of course, the antibody levels fall. As we eliminate the virus, we don't need them anymore, but they do not fall to zero, and this is a trick. We keep a low level. And the other thing that we keep are memory B cells that stick around, memory B cells that are much faster. So we're not making them from scratch. So the next time we get infected, we immediately jump up very quickly the next time we get exposed and we don't get an infection. So a little nuance here. The trick of a vaccine is to get the body to make antibodies or have antibodies or memory B cells, so that when a person gets sick with the exposure, immediately the antibodies come up. Or maybe we can have a situation where they already have the antibodies. And actually, if you're vaccinating during a pandemic, it would be better to get the people to already have antibodies. If you're vaccinating in childhood, you just want them to have like these sort of memory B cells floating around. So the paradigm for that type of vaccination comes from polio. And there are two main approaches. One is to just give what's called a derivative protein. I'm probably spelling it wrong, but you get my idea, a derivative protein. What a derivative protein is if you remember, we portrayed the virus like this, and remember the virus had certain proteins on its coat. So we don't give people the whole virus because that could infect them. We just put this part into people's body. So we make a syringe full of this protein, and we give that to people, and the people produce what? They produce the antibodies against it. Another thing that we could do is we could actually give them the virus, but we ruin the virus a little bit. The virus doesn't infect people, but it still has its proteins, but it can't make you sick. So then, of course, you're able to make antibodies against this weakened virus, and that's called attenuated virus. And this was what was elaborated on during polio, and this actually is what was the Salk vaccine, and this is what was the Sabin vaccine. A third approach would be to take another virus, so another virus that looks different, like let's say a virus like this, that had a different identity, let's use blue, another virus that has a different identity, and to use genetic engineering to put on that virus's coat the COVID protein. So even though this virus is relatively harmless, it's a sheep, it's got a little bit of the wolf's clothing, and then we'll be able to make good antibodies that will react against this virus, but it'll also react against COVID. But the amazing thing with the Moderna vaccine is what they are actually doing is that they're giving people in the syringe, what they're giving people is not the protein and not the virus. What they're giving them is the RNA. They're injecting into the body the RNA. And so what happens is the RNA comes into my body, and then my cells make this protein, make the virus protein, and I make antibodies against that. So if we imagine this is my cell, here's my nucleus, and here's my factory, my ribosome, R. And what we do is we give an external copy, like giving an external recipe that comes from the outside. It comes from this needle of these RNAs. And what these RNAs code for is this COVID coat protein. And so my body starts making not the whole virus, just this protein of the virus. And then some of it gets outside the cell too. And then my body sees these things. It doesn't see the whole virus. It doesn't see the whole virus. It just sees this part. And I didn't even give it this part. I gave it the recipe to make that part. I gave it the recipe, and then my body makes antibodies. So the innovation of this vaccine is that we're not giving the protein like we did with the the Salk vaccine. We're not giving the protein, we're giving the code, the recipe to how to make the protein. So we could either give the protein, and then the body will make antibodies. And it's nice because you haven't even seen the whole virus. You've just seen the protein on the coat. You've only seen this part, and you haven't been exposed to the virus. But the problem is that proteins are very hard to make in the lab. But what Moderna realized, because that's what they were interested in developing something that was scalable, fast, that would work in the time frame of a pandemic. What they realized is that you could give the RNA, my cells will make the COVID protein, and then I'll make antibodies. And that's the amazing thing. So once again, instead of giving me the viral protein, they're giving me the recipe of how to make the protein. I make the protein, which I've been drawing all along like this, and then I make the antibodies against it. So I'm making 2 steps. And it's easy because it's easy to photocopy recipes. So you could do this in a very, very fast time frame. And you could actually do it so fast. RNA could be made so fast that you could have enough of it to vaccinate the whole world. Protein would be much, much harder. I was skeptical. I thought, wow, if you give me this RNA, I'll just chew it up. I'll recognize this as foreign RNA. I'll never turn it into the protein. But that's the ingenious of how they got an RNA that could get into the cell, trick the body to make the protein, and then the body makes antibodies against the protein. The politicians need to slow down. They need to stop pushing us back to work. They need to back up the science. They need to keep us safe, and the technology will work. When they tell you that they might not be a vaccine, they have no data to support that. They're just saying it because they want to push you back to work. Do not listen to them. Everybody, rally the public. Love the science. Work with the science. We can fix this. But we need a global world where we're not slaves to our technology, where we're not putting people, the elderly, the sick, the homeless, vulnerable to just keep on dying. We cannot live like this anymore. We need economic and social justice. We need a new world. And the people who are in power don't want to face that. They don't want to face it. They want to push people back to work. They don't want to wait to vaccine. They don't want to learn the lesson. We can have a vaccine, but we're going to have to, first, it'll take time to make this. So we'll have to learn how to share, how to make sure nobody starves, how to not push anybody back, how to not go to how things were. And then we'll have the vaccine, and we'll all emerge in a kinder and gentler sunshine. And we'll be able to live and survive. But in that interim, in these crucial 5 months, while we're making these photocopy vaccines, and thank goodness it's 5 months, because if we were waiting for the protein, it would be 2 years. In that crucial 5 months, we're going to learn how to look after each other, how to make sure nobody starves, how to make sure nobody is hurt, how to not be hoodwinked by mercenary politicians that would let us die instead of doing what's right and what needs to be done. Thank you.